Hello everyone. We have learned the principles for handling the abnormal phenomena of the circuit breakers earlier. So, in practical work, how should we handle the situations where the circuit breakers fail to close? In this lesson, let's learn about the practical cases of the circuit breaker failing to close together. We believe that through the study of these cases, you will have a deeper understanding and experience of the handling of the circuit breaker failing to close. Firstly, let's analyze the main wiring diagram in the case study. First, an analysis of operating mode. First, dual bus operation at a 1220 kV station. Second, the 2211 and 2213 circuit breakers operate on the fifth bus of 220 kV. Third, the 2212 and the 2214 circuit breakers operate in the fourth bus of 220 kV. Fourth, the 2245 circuit breaker connected to the bus is closed. Fifth, the bypass number 6 bus of 220 kV and the 2246 circuit breaker are in the hot standby state, and the 2246-4 and 2246-6 disconnectors are closed. The abnormal phenomenon that occurred in the case is that the 2245 circuit breaker connected to the bus tripped without any fault, and the dispatcher ordered the bus 2245 circuit breaker to be closed. On site, it is reported that the 2245 circuit breaker could not be closed. So how to solve this problem? Firstly, we should consider the need to put the bus tie 2245 circuit breaker in maintenance mode. Secondly, it is important to note that when the bus tie circuit breaker running on the dual bus stealthily trips and fails to close, it is not possible to directly close the dual knife switch of a certain component at the same time. Instead, the two buses must be operated in a closed loop through a bypass circuit breaker. The first step in handling the abnormalities is to close the 2246 circuit breaker. Charge the 220 kV number 6 bus normally. After that, and then open the 2246 circuit breaker. Here, the main purpose is to ensure that the number 6 bus is charged normally, and there are no abnormalities in the number 6 bus. The reason for opening the 2246 circuit breaker again in the future is to prevent the problem of load closing. When the 2116 circuit breaker fails to close, the second step is to close the 22116 disconnector, close the 2246 circuit breaker, close the 22114 disconnector, and use the 2246 circuit breaker to close the 220 kV number 4 and number 5 bus. After operation, close the double switches of the 2211 circuit breaker. The third step is to open the bypass 2246 circuit breaker and open the 22116 disconnector. The fourth step is to switch the 220 kV number 5 bus from operating to standby mode and switch the bus 2245 circuit breaker to maintenance mode. Because the bypass circuit breaker can only carry one circuit at a time. Repeat the above process to invert the 2213 circuit to the number 4 bus. Finally, the number 5 bus was emptied. Finally, please think about this question. Why can't the double knife switches of a certain component be directly closed simultaneously when the bus circuit breaker fails to close after tripping accidentally? The key here is still the equipotential. When the bus fails to close, it cannot form the equipotential, which leads to the problem of load closing, due to the direct closing of the double knife switches of a certain component. That's all for this lesson. Thank you.